2023 National Electrical Code, specifically Article 314.17a, addresses the requirements for installing metal plates with surface-mounted nail-on boxes. The code states that where the back of a surface-mounted nail-on box extends more than 1/4 inch beyond the surface of the wood member behind it, a metal plate at least 40-inch thick shall be installed between the box and the wood member. This provision aims to protect the electrical box and wiring from potential damage. An inspector may interpret this code provision strictly, requiring metal plates on all nail-on boxes that protrude more than 1/4 inch beyond the studs. This interpretation emphasizes preventing any potential damage to the box or wiring. An installer might disagree with this interpretation, arguing that the code only requires metal plates when the protrusion exceeds 1 1/4 inches. The installer may believe the inspector is misinterpreting the code and applying an unnecessary requirement. The forum's opinion on this issue is likely to be divided. Some members may agree with the inspector's strict interpretation, prioritizing safety and code compliance above all else. Others may support the installer's argument, emphasizing a more practical application of the code. Ultimately, the interpretation of the code rests with the local authority having jurisdiction or AHJ. The installer should discuss the issue with the AHJ to clarify the specific requirements in their jurisdiction. This discussion can help resolve any misunderstandings and ensure compliance with the local code. Several additional factors could influence the situation. Firstly, the inspector may have concerns about potential damage to the nail-on box if it protrudes significantly beyond the studs. This concern is rooted in the possibility of the box being struck or subjected to pressure, potentially damaging the wiring or connections inside. Secondly, the installer may argue that the plastic material of the nail-on box is sufficiently durable to withstand any potential impact or pressure. The installer may point to the box's construction and material properties as evidence of its ability to withstand normal wear and tear. Thirdly, the installer could consider using a different type of electrical box that does not protrude as far beyond the studs. This could be a practical solution to avoid the need for metal plates altogether. Choosing a box with a shallow profile can eliminate the protrusion issue. When interpreting electrical codes, it's important to consider the context and intent behind the regulations. The purpose of requiring metal plates behind nail-on boxes is to protect the electrical system from damage and ensure safety. However, the specific application of this requirement can vary depending on the situation and the interpretation of the AHJ. To ensure compliance and avoid potential conflicts, it is always best to communicate with the local inspector and seek clarification on any ambiguous code requirements. This proactive approach can help prevent misunderstandings and ensure a smooth electrical installation process. The thickness of the metal plate is also a critical factor. The code specifies a minimum thickness of 40 inch to provide adequate protection. Using a thinner plate may not offer sufficient resistance to impact or pressure, potentially compromising the safety of the installation. The material of the metal plate is also important. It should be corrosion resistant and suitable for use in the intended environment. Galvanized steel or aluminum are common choices for metal plates used in electrical installations. When installing metal plates, it is important to ensure they are securely fastened to both the electrical box and the wood member. This can be achieved using screws, nails, or other appropriate fasteners. A loose or improperly installed metal plate may not provide adequate protection. It's also important to consider the size and shape of the metal plate. It should be large enough to cover the entire area of the box that protrudes beyond the stud, providing maximum protection. The shape of the plate should also conform to the shape of the box to ensure a secure fit. The National Electrical Code is a comprehensive set of regulations that govern the safe installation of electrical systems. It is updated regularly to reflect the latest technological advancements and safety standards. Staying up to date with the latest edition of the NEC is essential for all electricians and electrical inspectors. In addition to the NEC, local jurisdictions may have their own electrical codes and regulations. These local codes may be more stringent than the NEC, so it is important to be aware of and comply with all applicable codes. When installing electrical boxes, it is also important to consider the type of wiring being used. Different types of wiring have different requirements for box fill and support. Following the manufacturer's instructions and the NEC guidelines for wiring installations is critical for ensuring safety and preventing electrical hazards. Electrical safety is paramount in all electrical installations. Always to energize circuits before working on them and use appropriate personal protective equipment such as gloves and safety glasses. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Proper grounding is another essential aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Ensure that all electrical boxes and equipment are properly grounded according to the NEC guidelines. In addition to the specific requirement for metal plates behind nail-on boxes, the NEC also addresses other aspects of box installations. These include box fill calculations, support requirements, and protection from physical damage. Understanding and complying with all of these requirements is essential for ensuring a safe and code-compliant electrical installation. When in doubt, consult with a qualified electrician or electrical inspector. They can provide expert guidance and ensure that your electrical installation meets all applicable codes and standards. The NEC also provides guidelines for the installation of electrical boxes in different types of walls and ceilings. These guidelines address issues such as fire stopping, soundproofing, and structural integrity. Following these guidelines is important for ensuring that the electrical installation is safe and does not compromise the integrity of the building. The use of nail-on boxes is generally limited to specific applications such as new construction or renovations where the wall or ceiling is open. In other situations, other types of electrical boxes may be more appropriate, such as remodel boxes or surface mount boxes. Consider the specific requirements of the installation when selecting the appropriate type of electrical box. The NEC also addresses the issue of box fill, which refers to the maximum number of conductors and devices that can be installed in an electrical box. Overfilling a box can create a fire hazard, so it is important to calculate the box fill correctly and ensure that the box is not overfilled. The size of the conductors and the devices being installed will affect the box fill calculation. The NEC provides tables and formulas for calculating box fill based on the size and type of conductors and devices. When making connections inside an electrical box, it is important to use appropriate connectors and ensure that all connections are tight and secure. Loose connections can create a fire hazard, so it is essential to take the time to make proper connections. The type of connector used will depend on the type of conductors being connected. The NEC also addresses the issue of cable support. Cables must be properly supported to prevent strain on the connections and to protect them from physical damage. Cable supports can be in the form of staples, cable ties, or other approved methods. The spacing of cable supports will depend on the type of cable and the installation environment. When installing electrical boxes in wet locations, it is important to use boxes and fittings that are rated for wet locations. These boxes and fittings are designed to prevent water from entering the box and causing electrical problems. Wet locations include areas that are subject to direct exposure to water, such as bathrooms, kitchens, and outdoor areas. The NEC also addresses the issue of fire stopping. Fire stopping is the process of sealing openings in walls and ceilings to prevent the spread of fire. Electrical boxes can create openings in walls and ceilings, so it is important to ensure that these openings are properly fire-stopped. Fire-stopping materials must be approved for use in electrical installations. When installing electrical boxes in fire-rated walls or ceilings, it is important to use boxes and fittings that are rated for fire resistance. These boxes and fittings are designed to maintain the fire rating of the wall or ceiling. The fire resistance rating of the box or fitting must match the fire resistance rating of the wall or ceiling. The NEC also addresses the issue of accessibility. Electrical boxes must be accessible for inspection, maintenance, and repair. This means that the boxes must be located in a place where they can be easily reached without having to remove permanent fixtures or structures. The NEC provides specific requirements for the location and accessibility of electrical boxes. When installing electrical boxes, it is important to avoid damaging existing wiring or plumbing. Use caution when cutting into walls or ceilings to avoid hitting concealed wires or pipes. If you encounter any existing wiring or plumbing, contact a qualified professional for assistance. The NEC also addresses the issue of voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause electrical equipment to malfunction or operate inefficiently. The NEC provides guidelines for calculating voltage drop and for selecting conductors that are large enough to minimize voltage drop. When installing electrical boxes in areas where there is a risk of physical damage, it is important to protect the boxes from damage. This can be achieved by using boxes that are made of durable materials or by installing protective barriers around the boxes. Areas where there is a risk of physical damage include garages, workshops, and industrial environments. The NEC also addresses the issue of bonding. Bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault current. Bonding is essential for preventing electrical shock and for ensuring the proper operation of overcurrent protection devices. All metal electrical boxes, conduits, and equipment must be properly bonded according to the NEC guidelines. The NEC also provides guidelines for the installation of electrical boxes in hazardous locations. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. Electrical boxes and equipment used in hazardous locations must be specifically designed and approved for use in these environments. The NEC classifies hazardous locations into different classes and divisions based on the type of hazard present. When installing electrical boxes in damp locations, it is important to use boxes and fittings that are rated for damp locations. Damp locations include areas that are subject to moisture but not direct exposure to water, such as basements, crawl spaces, and covered porches. Damp location rated boxes and fittings are designed to prevent moisture from entering the box and causing electrical problems. In conclusion, the interpretation of the NEC regarding metal plates behind nail-on boxes can vary. Communication with the AHA is crucial for clarification. Factors like potential damage, material durability, and alternative box types should be considered. Always prioritize safety and code compliance in electrical installations.